In the last few hands-on sessions, we tried different aspects of list, dictionary, tuples. Now it is important for us to understand the last one, sets. So what is a set? So set is unordered collection of unique elements. Now can we create few in our Jupyter notebook and see how this works? So how do you create a set? Just like you have the tuple, dictionary and the list, same way we have a set function. All you have to do is you need to put across the brackets and just pass these values to it. A set is created. So my underscore set equal to set of the values. Now when I execute this, the new set is created in the name of my underscore set. Now set takes only single representation of each value. So let me show how this outcome comes in. When I print my underscore set, you can see that it is just the unique elements from the list is getting added to the set. Even though I have around 10 to 12 values that have been passed across to the set, it is not storing all the values in the set. It has just taken only the unique elements and removed the duplicates. It has only taken the unique elements like 2, 4, 5, 9 and 10 and removed all other duplicates. Where do you think this particular concept can be used? Think about it. Do you see any specific applications for sets? Something for you to ponder. Now, how do you add a new element in a set? You have understood that set doesn't carry any duplicate values. Now, having understood that, let's play around and create some new elements in a set. How do you do that? My underscore set dot add. Add is the function that we use to keep adding elements to the list. When I add 50 here, it's going to add it to my underscore set. And when I print it, you will see that apart from 2, 4, 5, 9 and 10, I've also added 50 to the list, to the set that I've created. So I've got 6 elements in the new set that I've created. Now, a simple homework for you. Can you try adding the same 50 again to this particular set? You know that the duplicate is not allowed, right? Now try it out and see what comes out as outcome. Something for you to learn. What kind of operations you can do on set? So I've got 2 new sets containing integer values, set A and set B. As you can see, all unique values. So 2 sets are going to be created. Now I can find out the intersection between the 2 sets. Since they are unique values, I can find out what kind of intersection that exists between 2 sets. That is a common points, common values that exist across these 2 sets. So what is the property? What is the function that I'm going to use? I'm going to use the intersection function. So set underscore A dot intersection, and I'm passing set underscore B as a parameter to it. Now when I execute, how do you think the outcome will be? You can notice it very clearly. You have very few common elements. Even though the total number of elements across A and B are more, there are only 5 elements which are common across set A and set B. That is 2, 4, 6, 8 and 10 are the common elements, and that's the outcome that you get when you try intersection. The same way, I can try union. Union means I'm going to find the total number of unique elements that are there by combining both the sets. What is the function I'll use? I'll use dot union. So set underscore A dot union, and I'm passing set underscore B as a parameter. Let's execute and see. Now do you see all the unique values put across here? And this 2, 4, 6, 8, 10, which came as the intersection outcome, is represented only once in this union. So even if it is repeated twice or thrice, it's not going to come out. It's only the common unique values or the total unique values that are available in both these sets. That's what is going to come out as a result here. Okay, in the last few minutes, you have understood the different operations of sets. Now, I want you to answer a simple question for me in the comment section. You have understood 4 different types of data structures: list, tuples, dictionaries, and sets. When do you use what? In what context you're going to use these data structures? You have learned the properties of these data structures, so those properties are going to help you to understand where it can be applied. Can you think about it and can you put it in the comment box? I'd love to check that. Thank you. See you in the next section.